CPU stands for Central Processing Unit. It's a kind of it's the computational unit which is in the heart of every computer.
In all cases, everywhere you have a CPU. The CPU is at the opposite of accelerator or GPU. A CPU is generic, can do everything. But if you want to have something very focused, for instance, cryptographic operations or graphical operations or quantum operation, in this case, you need a dedicated accelerator.
What I tried to explain at the beginning of the people about semiconductor is there is mainly three kinds of semiconductors for me. One is ASIC, which is a semiconductor which has the implementation of the algorithm inside it. So if you want to change it, you basically need to regrave it. You have FPGA, which kind of programmable ASIC, but maybe you can temper a little bit there. And the one which are more versatile, which are not the most efficient, because ASIC is very efficient, but are the most versatile. And that's the one we build computer with. And the two others are some things we will use as a peripheral and coprocessor. Am I right when I explain that?
I may add another category, which is so-called ASSP, application standard products. So, and especially in the past, where the cost of designing a chip was reasonable, let's say for 1 million, a couple million, lots of, let's say, industrial company were used to develop or have developed their own ASIC to fulfill a very specific demand. So I have a specific operation I want to do. I can give, let's say, 1 million to a service company, and this service company will build a specific chip just for me, which will be fully suited for my needs.
And it's still something that happens?
Or yes, it still happens, but it's just more and more expensive. Because, for instance, if you want to have a very specific chip for a compute need or something like this, for instance, Apple, they have developed their M2 processor, M3 processor, and we may back to this later on.
So it's become more and more expensive.